Programming for Mad Scientists and Evil Geniuses by Walker Hale. This will be a 45-minute talk, followed by a 10-minute question and answer period. If you have a question, please come to this microphone to ask that question. Thank you.
Okay, thank you, everyone. So that is my name, that is my affiliation. I work at the Texas Medical Center. And they do good things, which is not going to be the topic of this talk. Okay, so this is my thesis. Python is an ideal language for many groups. I mean, part of the Python community is all about diversity, and this diversity includes what we normally think of as two very different camps, mad scientists and evil geniuses. And Python is such a broad language, even do-gooders, I hope, will get some benefit out of this talk. They'll find some way to apply these techniques if you have to. And before I go on, I don't know if there are any contributors. Well, I mean, I'm sure there are lots of people here who have contributed to Python. Even if you're not core contributors, you've contributed libraries. There's this huge body of people who've contributed, and I want to give thanks to them. All right, so let's talk, first let's define our terms. The mad scientist does things because it's cool. The evil genius has a goal. He's going to get to that goal no matter what or who gets in his way. And each is not going to be concerned about standards or sanity, morals, whatever. Okay, so the typical mad scientist, just channel that for a moment, even if you're more of the evil genius type, or even if you're a do-gooder. You want to do, the classic things are to create something from nothing, to do the Frankenstein's monster, create life from the absence of life, or to do some mutation ray and just take something and make it very, very different. That's what a mad scientist likes to do because it's just so incredibly cool. And a lot of those same things will have evil genius applications. So I'm going to focus primarily from a mad scientist point of view, but everything here has this evil genius duality to it. They're two sides of a coin. Okay, so this is what we're going to be working with. Synthetic functions, synthetic classes, synthetic modules, Monkeypatching, and the little-known, seldom used, considered toxic site customized.py. Okay, so what do I mean by a synthetic function? And for all of these synthetics, the idea is something that's going to be executable for which there does not exist corresponding source code. And so here's a simple example of this where I've got a string literal. We're going to we construct an empty dictionary just to serve as our namespace. We exec that string in that dictionary, and now we see the dictionaries in there. And you'll notice that whenever you do one of these things, if you don't have built-ins already in a namespace, Python will just add that for you. So whenever you do something like this, you get a dictionary, you don't want to just print that dictionary out because it's going to go on for page after page after page with all those built-ins. But anyway, so now I've got this dictionary that's my namespace. It's got that thing in there, and I can actually run that. So I've created a function spam for which there does not exist actual Python source code. There's just a string literal, and now I have a function, and it's a true function. Okay, synthetic classes. A class is just a dictionary wearing a dress. I mean, that's all of Python. It's dictionaries all the way down. Just dictionaries pointing to dictionaries. And classes are certainly like that. And so it's fairly straightforward to construct a class. All you've got to do is construct a dictionary. You throw stuff in there. And what that stuff is, well, in this case, I was using actual functions. But I could have synthesized those. They could have come from user input. Some formula being typed into a spreadsheet-like interface. And I'm going to accumulate those into a dict, and then I just call the built-in function type that Python provides, which normally you might think of as a way of inspecting the type of some object you have. But the primary function of type is the top level of the object hierarchy in Python. It's the ultimate meta class. And its job is to construct a class. And the way it does so is you pass in a string that will be the name of a class, the tuple that will be all of the ancestors of that new class, and a dictionary. And what's really going on when you're running the normal Python source code, and you go class, foo, parenthesis, object, colon, indent, is Python hands you an empty dictionary. All of your code is running inside of that initially empty namespace. At the end, when you exit that block, Python will have accumulated that dictionary. It will then take that dictionary, the name of your class that you had as the first thing after the class statement, and then any superclasses you defined, which it'll create as the tuple, and pass all of that to whatever meta class is relevant at the moment. If you didn't specify a meta class, it's going to pass it to the built-in meta class type. But so it's useful to think about this because if you're ever going to work with meta classes, you have to kind of grok that before meta classes are going to make sense to you. Anyway, so now I've got this synthetic class, and what is a class in Python but one, a delegate that's going to receive method calls from instances, and two, a factory that's going to construct new instances. And so there I am just constructing an object from that synthetic class, and now I can run it, and it's going to do all the right thing that you see down at the bottom. So you could run this, and you'd get the same results. What is a module? In Python, a module is even less than a class. A class is a dict and address. A module is just little more than a dict that has a few special keys inside it. And by convention, gets stored inside sys.modules. So what does Python do when you do an import for some module that has not yet been imported? Assuming the module is pure Python, what's it going to do? It's going to create an empty namespace. It's going to run that Python code in the context of this empty namespace. Having accumulated all of that, it's going to just dress it up a little bit to turn it into a module, and then shove it into sys.modules, and there you go. There's your newly imported module. And if you then import it later on, it's already there. Python checks to see, oh, it's already in there. Well, here you go. And hands you the module that was already sitting in sys.modules, which is a dictionary, or dictionary enough like. So there you go. I'm just going to, you can create a module, if you really want to be up and up, and so you use the, Python provides this machinery new, and you can go new.module and do all this stuff, and just throw stuff in there. But you have to insert the module into sys.modules yourself. And so the point is, anywhere else in code, after you've done that sys.modules synthetic equals my module, any other time in Python, some other totally different file, if it does import synthetic, it's going to see the module that you just stuck in there. And there's nothing to stop you from sticking in a synthetic module before a real module loads, or just replacing a real module that was already there. More on that later. Okay, so I hope you like it just because it's cool. I've sort of peeled back the veil of Python a bit, I hope, for a lot of you, and shown that there's really no there. Python is just a bunch of dictionaries pointing to each other, whether it's a module or classes, namespaces, or just dictionaries. Yes, functions wrap code objects, but they can be constructed. But if you want some good use to put to these things, well, you can take user input. Like a user types an expression. You want to turn that user expression into a function. Well, there you go. You synthesize a function. Both for functions and classes, if you were writing some kind of mapper between objects and something else, not necessarily an object relational mapper, but it could be some crazy object mapper to something else, but you need to construct objects by inspecting something else that's outside of your program, then you'd want to be synthesizing certainly classes and probably functions too. GUI frameworks, that could work out nice. It depends on just how you're going nowadays I'm not sure it'd be so useful. Monkeypatching, we'll get more on that later. That's the primary purpose of why you'd want to do modules. Because modules are so simple and so easy. There's no good reason to synthesize them. So if you're synthesizing a module, you're doing it for something that's kind of wicked. Okay, monkeypatching. So I said Python, everything is a dictionary, but really in Python, everything is an object. It's just most of Python is dictionaries, and all the rest of it is other types of objects. And functions, classes, modules are just objects in memory. They can be modified if they're pure Python, patched. They can be just swapped out for your own implementation. And why would you want to do this? Well, there's two reasons, if you're trying to be constructive, if that's what you're into. One reason is if you do this systematically, you now have aspect-oriented programming. You could weave in a security policy into a body of code that was naive of your security policy and just go, punch it in, punch it in, punch it in by decorating functions after the fact. You got some module, here's a bunch of functions. Normally you'd think, well, I'll just put a security decorator on top of this function. Well, yeah, you could do that. But if you wanted to really separate concerns, you could have some crazy monkey patcher come in after the module after the fact, grab all those functions out, decorate them, and shove them back in. Bwahahaha. And if you're systematic about that, you have aspect-oriented programming. The other use is third-party code. So you get some third-party code, and there's something wrong with it. It's almost what you want. It's not quite what you want. You want to fix something. And the right way to do this is to, hopefully if it's good third-party software, it's up on something, distributed version control, and you'd pull it down, patch it, get it working for you, post the patch up, and there you go. And if you're a good guy wanting to share your work with the rest of the world, that's what you should do. If you're selfish and you want to just take whatever that improvement is, maybe it's a trade secret, and you want to take this third-party code and twist it to be your way and not have anybody else know about it, your choice is either to patch that code, keep the patch a secret, and have to keep updating that patch in response to the updates to that third-party code, or monkey patch the code. Just alter the code in memory on the fly without touching the corresponding source code. Okay. So, if you've got some third-party code and it's bothering you, that's typically a module. You've got two choices with regard to this sort of monkey patching technique. You can either modify it, like I described earlier with if you were doing the aspect-oriented programming route. Treat it like a dictionary. You just open it up, look at all the keys, look at all the values, say, okay, which of you are functions? Or like if you just want to do one or two of them, you already know which ones are offensive, and you just put a wrapper around them or a replacement that might delegate to it, and shove the new function in. But suppose that this module you're working with is not pure Python. It's actually a C extension. Well, that's not going to work. If it's a C extension, the functions that you pull out of it are sort of wrapped function pointers. You can't change them. You can't pull Python bytecode out of them because it's C underneath. And you can't stick replacements in because there is no dictionary there. So what are you going to do? Well, that module may not be a dictionary, but sys.modules is. And so what you can do is say, well, fine. I will just write my own version of that module that mostly delegates that module. If I'm pretty much happy with what it's doing, I'm just going to keep writing functions that are delegating over. And in the few places that you were offended, you do your fix. And then once you're done, you have a value now. That dictionary is the value. The key was the name of the module that was bothering you so much, and you just take that key and that value and insert that back into sys.modules. So sys.modules, square bracket, name of offensive module equals the dictionary that you've just constructed. Or if you really want to be on the up and up, you could use that new.module I showed you about, where it's not just a dictionary, but when you do this, that approach right there, new.module, I mean, what you've got is, it's a dictionary. And push it in. Okay. All right, so monkey-patching classes. Let's talk about, so you've got some class. Monkey-patching modules is easy. You just, here's a key, here's a value. You just change the value with some other value. Monkey-patching a class is a bit trickier because when you were constructing the dictionary of that class, and it contained functions, and you pass that dictionary to type, or Python's doing this for you because you've got a normally defined class in code. What you get inside the dictionary for the final resulting class is not just those bare functions. What the Python metaclass does, what type does, is it inspects the dictionary, it says, okay, what do you have in here that's a function? Anything that you've got that is a function, we're going to turn into a method, an unbound method, and stick it in there. And so if you have an instance of that class later on, and you say the method was foo, and you've got an object x, and you go x.foo. Well, what Python did is it went to the class, and it said, all right, let's look up foo. Okay, we found it. What we now have is an unbound method. Now we're going to bound that method to x, so that the result, x.foo, is an object that is aware both of the function and of the instance. And that's how, when it gets invoked, the reference to the instance is passed into the function as the parameter by convention self. Anyway, so there's some trickiness to dealing with methods in classes. You can't just swap them out. You can do that for instances, but even then, it's not going to quite work out right. You've got to go back to that new module that Python provides that lets you create these special kinds of objects, and you've got to create a new instance method. Now, in this particular case, you see where it says none. That's because at this point, there is no instance. You're operating at the class level yet. It's not, if you wanted to stick this into an object, you'd actually stick a reference to the object itself where none is. And at that point, you could actually monkey patch a single instance, leaving the other instances unperturbed. Anyway, so that's the basic idea of monkey patching class is the simple things, you just go ahead and swap them. The methods, you've got to call new instance methods, but other than that, things are pretty straightforward. And here's an example of monkey patching instances. So I've got X and Y, they're both instances, and I decide that I want to graft something onto X. So X has a method that Y does not, and there you go, you could do that. And if the class had actually defined a span method, then X would have had the version you see appearing down here, and Y would have whichever version had been defined in the class. In effect, you could think of X as being a single instance subclass of that class. So if you need to just do a single instance, that's how you do it. Okay, so I hope that was good for a lot of you. And sort of peeling back the curtain and showing how you can just muck with the internals of Python without going too deep. Now, sometimes you want to be even more forceful. Everything I showed you so far only works for modules. You're importing some third-party library, and you want to patch it in memory after the fact. But what if what you are having trouble with isn't executable? Here's a Python script, in Unix land with a shebang line on it, and it's just running Python, and you don't want to maintain your own separate version of that top-level main file. What do you do then? Well, turns out there's this module called site customize. And if site customize.py occurs anywhere in your Python path, the Python interpreter will import that module very, very early in the booting process of the Python interpreter. And you can do all sorts of things in there. There are some tricks to actually get it to work right. So if you wanted to monkey patch an executable, if you could adjust your Python path before the executable starts and have it contain a directory that had site customize.py, well, now even that theoretically self-contained executable is now getting monkey patched. Okay, so I'm going to show you some examples of how you do that. This first example was something I encountered where I did have some third-party code that I wanted to patch. And my problem was that the third-party executable was using the wrong Python interpreter. Now, we know that, or at least hopefully most of you know, that in a Unix environment, there is a typical standard custom value that you should have in the shebang line. You know, pound, bang, user bin env space Python. That's what you're supposed to do. But it's not always the case that you get that. You know, if it does that, then you can control which Python interpreter runs just by setting your path environment variable, and everybody's happy. But a lot of times, well, maybe not a lot, but enough times to be annoying, it'll actually be a fully qualified path to some particular interpreter. And what if that interpreter is wrong? Well, now you've got to patch it. And yes, it's a one-line patch, but I'm not a tolerant man. So in this example, you see I've defined executable as the path to the one true Python that I consider. And I'm doing something a little spooky here. Original import equals underbar, underbar, import, underbar, underbar. So that should be foreshadowing. Yeah, that's the gun on the mantelpiece. And here's my patch. And my patch is, I'm defining a function whose name is underbar, underbar, import, underbar, underbar. Yeah, that's a loaded gun on the mantle. The body of the patch, you see I am checking argv, sys argv, and what I'm looking for is the executable what I want it to be? Now, there's a problem with this, and you notice I've got this if has adder sys argv. Remember I mentioned that site customize gets imported really, really early? I mean really, really early. If you read the C Python source code, site gets invoked. The site module gets invoked, which loads site customize, before sys.argv has been defined. So we got a problem here. I couldn't just take a quick look at it, in bare code in my site customize.py, just have that if statement. Well, I wouldn't even have an has adder. I would just check. So what I'm going to do here is a bit of a black hat man in the middle technique. If I actually have it and all is good, then fine. We just let everything work normally. But if not, this is where I'm doing it. So if I've got an executable, if I don't have an executable yet, I'm going to install import into the built-ins module, my import. So the strategy here is I'm putting a landmine in front of the executable. Pretty much every executable you can imagine, and certainly any one that would actually cause offense, will be doing imports. And so if we are really, really early in the loading process, we're before that program has imported anything. So if we hack the import mechanism itself and put our little tripwire there, then the moment the executable tries to import anything after sys.argv has been defined, it's going to hit our tripwire, and if the Python interpreter is not what I thought it should be, well, we're going to os.execv, in other words, kill the current process and replace it with the Python I want, passing in the sys.argv. That's why I very much needed that. And so there you go. I've actually, with these very few lines here in site-customize.py, and then sticking that in your path, you're able to force the Python interpreter to be what you want it to be, regardless of the shebang line. Okay, now, here was another example I encountered. This was some other third-party executable software, and what it was doing was refusing to run because I did not have root privileges. And I was in a communal compute environment where they didn't want to give me root privileges. So, and here's this software that just was refusing to run, even though it perfectly well could have run. So, what to do? And well, I don't need to note from my mother, and I don't need sudo, so let's just hack our way through it. What I did is I said, well, okay, how's it finding out I don't have root privileges? Well, we can fake it. And so, yeah, the PWD module is what systems on Unix use to figure out who you are. And, well, I'm whoever you want me to be. So I hack my version, I stick it in, and there you go. Now I'm replacing the PWD that was in sys modules with a fake module that had only one function in there. So if any other functions got called, I'm going to get attribute errors exceptions, because they're just not there. But that's okay, because if it's okay if code breaks as long as it breaks early and loudly, and then I'd know, oh, I forgot to delegate a few more things, and I'd add them. I'm whoever you want me to be, and I'm very rich. Okay, and like I mentioned, when to do stuff like this is when you're dealing with stuff written in C. The only way is to synthesize a replacement that's going to delegate to the original as appropriate and inject your behavior as necessary. Normally, just patch the few functions you need, and if you forgot a few, well, you'll get a complementary stack trace, and you'll know that, I forgot one. Another thing you can do, and I mentioned this at the bottom, is, well, you could, instead of sticking a true module into sys.modules, it turns out you don't have to have actual modules in sys.modules. You can have any object in there, as long as it responds to getAttr. So you can create an instance, and it could, and make it act like a function, and it could just dynamically do behavior based on function name. You could have it say, implement the method do underbar whatever, and it's going to print out whatever the whatever is, because that string was being passed in. You could synthesize your own behavior on the fly. Now, for performance reasons, if you're doing that a lot, then that could be a performance hit. But I already showed you how to synthesize functions. So if you find yourself having to do something like this and synthesize behavior based on dynamic dispatch, well, you could say, well, when I catch a function that I was supposed to have but didn't, I'll synthesize a replacement, stick it into myself, and then call it. Okay, now, this is also a problem in the Ruby community that makes it very easy to modify objects and classes after the fact, is you can drive people slowly insane, because if you're doing this and they don't know about it, you're creating this like false reality, and they start debugging, and lo and behold, things just don't make sense anymore. Why does OS get CWD return 42? That's not even a string. How is that happening? And if they've, there are two things are going to happen. They're either going to leave and just never come back, or they will eventually get to it, if they didn't go insane, and figure it out and become very, very angry. So you need control, because They get angry, they complain to their boss, they look at all the commits you've ever done and just roll them all back. And it was beautiful, and it's gone. So we have to find some compromise to deal with angry villagers, do-gooders, and it's driving people insane is a lot of fun, but it's not good for the bottom line. Okay, so these are my recommendations. If you're going to patch third-party code, do it seldom and do it publicly. Now, if you're going to do it often, then at that point it's not monkey patching. That is aspect-oriented programming. That's part of a framework, and the whole team's on board. That we're going to separate concerns, and here's normal execution, and here's security policy, and here's caching policy, and here's remoting policy, and it's part of like a broad aspect-oriented strategy. But if you're not going down that road, then it's do it seldom, do it publicly. And do it publicly is always. Do it seldom is unless you're doing aspect-oriented programming. Be aware that if you update third-party code, yes, it's less likely to be a maintenance problem than if you were actually patching the third-party code. But third-party code could still break it because you're likely patching implementation details that are subject to change. Some would say, well, you should really be submitting patches and be all on the up and up, and well, they can say that. Okay, and of course, whenever you're dealing with code that's not pure Python, you just have to synthesize. And it's not just C. If it's Java or if it was .NET bytecode, you got to synthesize. Okay. Now, there are a few more goodies. Now, everything here, I hope, you see, had not only a mad scientist thing, but an evil genius. I'm going to get what I want, and I'm not going to let anything stand in the way application here. There are a few more things about just Python in general that are good for evil geniuses. Python is something you could use with Metasploit. Some of the concepts here, like think about Selenium, if those of you who do testing. Selenium is a man-in-the-middle attack that was purposed for good. That's the whole concept there. It blew my mind when I first saw it. That's a man-in-the-middle attack, and you're using it for testing. That's awesome. This is more like for the evil geniuses, which are concerned about results, is there are things that Python does that you don't see in other languages as much to give you the capability of achieving like real speed when you need it. There's C types, there's Cython, there's PyPy nowadays becoming faster and faster. Now, every week it hits me that we didn't get the memo. We live in a golden age here. We don't have to buy a newspaper to find out what movie times are. We don't have to pick up a telephone to find out what the weather's going to be tomorrow. A telephone isn't a device attached to the wall whose sole purpose is making voice calls. We're in a different time, and we need to think like it and act like it. We're in a golden age. And so, yeah, reason wins over convention and superstition up to a point. You still have to cater to the peasants, but you have the reason and all these powerful tools that Python has brought here, so enjoy it. I don't know how we're doing for time, but we should go for questions. Okay, yeah, so if anybody has questions, please come up to the microphone, or I'll have to repeat your question, and that will make me angry.
Just to comment on inventing modules on the fly. Not everyone might be aware of this, but early versions of Django, like 0.95 or something, would actually do that. You define a model object, and it says, oh, well, that's actually not going to live where you defined it. That's going to live in Django.models, and it's going to look completely different from the code you defined. You're just telling Django how to define those modules. It was really confusing, and no one ever did it again.
And they hated it.
Yeah.
And they did a whole, let's get rid of the magic thing. It angers people, and then they start just burning the whole thing down. Anybody else? We're not paid to use up the whole time slot, so. Oh, yeah. You had a question?
Why does it say
Why what?
Why doesn't site-customize.py work in your current directory?
Okay, so the question was, why doesn't site-customize.py work in the current directory? I'm not sure, but I think the reason for that is there's the whole rules of what's happening in the site module. So module is what Python runs, which then turns around and runs site-customize.py and later on pulls in site packages. And there's path munging going on. And so I think one of the last things that happens, but I'm just guessing here, is adding the current directory to the beginning of the path. So you just have to Python path explicitly or have a .pth file or something that's going to force site-customize.py to be there early in the boot up process. Sir?
Generating code and synthesizing modules go together like peanut butter and jelly. If you're writing a parser generator, this is really handy. In PyMeta, I use that for taking a textual grammar description and then synthesizing a module from built code. So you get tracebacks with code that isn't on disk.
That's an excellent point. I mean, if you generate code and you stick it in, and you're going to get line numbers. And if you go further, I didn't go into the abstract syntax tree. If you actually go that route for deep code generation, you could actually set line numbers and make fake code potentially debuggable.
I tried that, but it was slower.
It didn't. Oh, it went slower. But certainly, generating code will give you a speed bump. If you're dynamically dispatching based on names and delivering some fake behavior, if you then generate a function that does that, you're going to get a speed bump.
New is deprecated and has been maybe since 2.5, I think. And types is a replacement in Python 3. Is there any particular reason to use new over types?
Yeah, this whole thing was Python 2 centric. I'm not aware of why you'd pick new over types. I mean, generally, Python 3 is a different language than Python 2. In any language, you should focus on the conventions, the idioms of that language. So Python 3 introduces a new way of doing it. You should try to do it that way if you're going to go crazy on Python 3. Anything else? Quiet and docile. I like it. Okay, we're done.